In this example, we're going to use another algebra trick. You've probably seen it before. It's called multiplying by the conjugate. But just in case you haven't seen this before, or if it's been a long time, to refresh, a conjugate is when you have two expressions that look exactly the same and they both have two terms, but the middle sign is the opposite. So for example, if I have the expression x plus 5, the conjugate of x plus 5 would be x minus 5. The two expressions are the same except for the sign in between the two terms. They're opposite. So those are conjugates. And when we multiply by a conjugate, a lot of times it will help us simplify things to make it where we can use the limit laws and direct substitution. Because if we look at this limit that we're asked to evaluate, you always want to first try to evaluate it by direct substitution because that is the easiest way to do it. But if you notice, if I try to plug -1 directly in as it is, I'm going to get 0 over 0. And that's not going to work. So we need to use some kind of algebra trick to manipulate the expression in a way that we can use direct substitution and the limit laws. So, and using conjugates is one of those tricks. Just like in the previous example, I show you how we can factor and simplify. That's another trick. So I'm going to rewrite this expression by multiplying both the top and the bottom by the conjugate of the numerator. So I'm going to multiply the top and the bottom by x plus 2 plus 1. Because this sign here is minus, if I want to multiply by the conjugate, I got to switch that sign. Now, when I distribute, this is going to end up being similar to the difference of squares because they're both the same except for the middle sign. So the two terms in the middle are going to end up canceling out. So I'm going to get the square root of x plus 2 times the square root of x plus 2 is just x plus 2. And then when I multiply -1 times +1, that's going to give me a -1. And the two middle terms are going to end up canceling out because they're going to add to 0 because they're going to be the same term, but one's going to be plus and one's going to be minus. Now, if I multiply across the bottom, I'm left with x plus 1 times the square root of x plus 2, and then on the outside plus 1. Now, when I simplify the numerator, I can combine the 2 and the -1, so that's going to give me an x plus 1 in the numerator, and on the bottom I'm left with x plus 1 times the square root of x plus 2 plus 1. Now I can get rid of the x plus 1 because they divide out and I'm just left with 1. So when I finish simplifying this expression, I end up with 1 over the square root of x plus 2, and then on the outside plus 1. So this expression here, we rewrote it so that it's written like this. Now I can use direct substitution. If I find the limit as x approaches -1 of 1 over the square root of x plus 2 plus 1. When I use direct substitution now, I'm going to get 1 in the numerator, and then in the denominator, I'm going to get 2. Because if I plug in x is -1, I get under the square root, -1 plus 2, which gives me a 1. The square root of 1 is 1, and then I add this one here on the outside, which gives me a 2. So this limit that originally gave me a difficult time with 0 over 0, just by multiplying by the conjugate, I end up simplifying it and making it a lot easier, and I get a limit of 1/2.